Hello everyone. Today's project is about FIR filter design in Zynq processor using VIVADO. So let's start it. First of all, we'll create a project. We'll name it FIR filter 1. As we are using the turn board, we'll select it. Next, finish. Okay, now first of all we'll create block design. We'll name it FIR filter 1 underscore BD. Now here we'll add Zynq processor system. Now first of all, to filter a signal we'll have to generate signals. So we'll create one sine wave generator. Here I'm creating one source, one Verilog module, it's sine module. So it's generating. Now we'll have to add the code. As you can see, as I have written already the code. Here it is the input clock, there is the output register. Here it is a function to read. We'll generate a sine wave based on ROM memory. So it is will generate one memory file here. So this function we are giving output the sine wave values. Now for values of lookup table for sine wave, we'll generate one memory file. So go to add source. So we'll create here memory file through this sine. Finish. Now you can see here the sine dot memory file has been generated. Here it is the sine memory file. So now the basic thing is now it is blank, so we'll have to fill the sine wave values. For that, one shortcut solution is there. This is a website which creates the lookup table for us. This is sine wave lookup table generator calculator. So number of point 1023, maximum point is 6 30 bits of row. So we'll generate it. Now you can see the lookup table has been generated. So we'll copy all the values and we'll paste over there. Now remember one thing, we'll have to replace all these things. Yes. Replace the commas also. Okay, now we are sorted. Now we have our memory file, this module file. Now we'll go to the diagram. We'll add module. Here is a sine wave module. It has been added here. Now we'll collect. Now we'll run the block automation. Then we'll connect this clock to this clock, as we are using 50 megahertz clock. You can see the clock one is 50 megahertz. Okay, now first of all we'll demonstrate one thing. Now we'll add FIR filter, the main component of this video. Now today I'll tell you how to generate and how to use this FIR compiler to filter it. Now here you can see there is a frequency response of the default mentioned coefficients, so we'll have to change it, as whatever sine wave we are generating, it is of signal of 50 kilohertz, so we'll have to generate one filter of passing 50 kilohertz signal. For this we'll have to go to MATLAB. Here we go. Here we can see this is the filter designer block. And now we'll use low pass filter, is FIR equiripple. Now we'll use, as we're using 1 megahertz sampling frequency, that would be 50 kilohertz. As our frequency is 50 kilohertz, so we'll have a bandwidth of 100 kilohertz filter bandwidth. Specify the order, let's have 50. Okay, now we can see in the 50 kilohertz it is showing almost 0 dBm, 0.3 dBm. Okay, now we'll export the coefficients of 1 over the variables export. So it has been exported here. So these are the coefficient values. You'll have to copy them. And we'll have to paste the coefficient values. Just I have pasted. Now the default it was showing 21, but as our filter order is 50, so it will show over there 51. Now going there, now it is showing 51. Now we'll see the frequency response. Yeah, it is like almost that. It is the frequency response of that, both the same. Yeah, we'll keep it single rate integer, channel specification basic. So our clock frequency is 100 megahertz. Implementation, this is signed quantities only, signed 16-bit full precision, and it has been by default it will generate 34-bit output with as whatever the coefficients values are there. Now these are the automatic generator. Will not change anything. Now click OK. Okay, now our module is ready, so we'll add them. Now we'll verify. Okay, it is clock is not connected. Okay, now again we'll verify it. Okay, validation successful. Now we'll create virtual wrapper. A wrapper file is generating. Now as wrapper file has been generated, we can see over there FIR filter 1 wrapper file also has been generated. Now we'll simulate it. Now through test bench we'll generate simulation settings. See this video it is the main component. This FIR filter 1 blocked wrapper file. It should be very long. Now keep apply. Okay. Now we'll run behavioral simulation. Now this has come. This is the waveform generator. Now we'll have to, if we go there, we'll have to add this the waveform. Now it has been added here. We'll have to add the FIR filter. It has also been added here. Okay, now we'll simulate it for 1 second. We'll have to click this one. Now we can see waveform is there. Yeah. This is a sine wave. This for the sine wave generator block. This is the clock. If we zoom it, you can see the clock. This is the clock. And here is the filter out data. This is exactly the same of output of the sine wave generator. So here it is showing that it is the FIR filter is passing the signal frequency. Now we'll stop it. Okay, sources, we'll go to the block design. Yeah, so that's a complete block diagram of FIR filter. So that's how you can generate one FIR filter in the VIVADO using the Zynq processor. Thank you so much. Please do like, share and subscribe my channel. Thank you.